Okay, so even if you couldn't do that part, you could still do the next because you have the volume. You have the actual function for volume. So I don't know why some people didn't just use this, even if they did get stuck with part one. So it says find the value of x which the volume of the box is maximum. Anything to do with max or min, you differentiate. So all you had to do here was differentiate, let it equal to 0, and then you're doing either your minus b or your null factor theorem. You could break it down first, actually, make it a little bit easier for yourself. So that's 32. So that's going to be x minus 8, x minus 4. So it ends up being x is 8 or x is 4. Now, how do I know which one's max or min? Well, I know this is a positive cubic, so max should be in that first position. So it should be the 4. Now, if I want to check it, of course, I can just do my second derivative, 6x minus 36, pop in the 4, and I get 24 minus 36, which is less than 0. Therefore, it definitely is max. So x is 4 for maximum value. And that was 10 marks. Find the maximum volume of the box. So the volume, of course, is length by width by height. But we have a volume formula, x cubed minus 18x squared plus 96x. And now I know what x is. X is 4. So anywhere there is an x, I replace it with 4. And when I work that out, I get 160 centimeter cubed for volume. Now, it does also ask you to find the other dimensions of the box. So our volume, again, is length by width by height. In our case, we call that x, y, z, or whichever order we used. We know now that x is 4. So how will I find my y and my z? Well, I suppose I need to think about, the volume itself, I know is 160, so I can put 160 there. So that's going to get me closer, that's 40, so that's going to get me closer to a value for y and z. Now, I still have to somehow get it in terms of one of the letters. So I go back, I think, then to one of these ones. So I'll probably go back to this one because it's the easier of the two. So y is equal to 18. 18 minus x minus z. Now remember, I know x is 4. So y is equal to 14 minus z. So I'm going to replace that down here. So instead of y, I'm going to do 14 minus z times z. The reason I'm doing that is because now that it's in the one variable, I should be able to work it out. So that's 14z minus z squared. And then I can do my minus b formula on that, for example. Or I could do my null factor law, whichever way. Whichever way you choose to do it. So minus b formula is probably just as handy. You end up getting that your z, we'll do it out. So a is minus, sorry, I'll bring it all to the one side first. So all to the one side is going to be z squared. So I'm going to put everything on the left. Minus 14z plus 40. So my a is 1, my b is minus 14, my c is 40. Minus b is going to end up being plus 14, plus or minus b squared, minus 4ac, all over 2a, which is 2 times 1, which is 2. So on my calculator now, I'm just speeding this up a little bit, so hopefully that makes sense. You can spend a little bit more time doing the minus b yourself and check it out properly. Okay, so I end up getting 10. And then if I do the minus, I end up getting 4. So z could be 10 or 4. And if I know what z is, then I can go back and find y. So y was 14 take z. So if z is 10, then y is 14 minus 10, y is 4. So when Z is 10, Y is 4. And when Z is 4, well, Y is going to be 10, then it's going to be the other way around. So maximum volume of the box, you can have either, well, you have to have X is 4. And after that, you can have combination of 4, 10, and 4, or 10, 4, and 4. So we did end up actually having two sides that were the same. So that was 10 marks.